Alright, so this is a continuation on vectors. So far, we've talked about what a vector is, what we have as the difference between vectors and scalars, the modulus of a vector, the direction cosines, and so on like that, and how to add two vectors and a component of a vector as well. So in this part of the topic, we are interested in talking about the scalar product of vectors and the angle between two vectors. So that's what we are interested in taking about. So let's take the first one. We have something called the scalar product. Now, scalar products. So scalar product is also known as the dot product. It is also known as a dot product. And why is it? In fact, probably the most important fact is that you should understand that at the end of the day, you get a scalar when you take the dot product of two vectors. And let's consider what we have. When you take this dot product of two vectors, you result to a scalar, and that is why we call it a scalar product, the scalar product of two vectors. So this is how it goes. Let's say we have a vector A, and vector A is defined as ax in the direction cosine of I, and the direction of I, and ay in the direction of j. Let's assume it is a two-dimensional vector. That's a vector in two components. And then we have another vector B. Say we have another vector B, and it is defined as bx in the I direction and by in the j direction. So the dot product is usually written as given as what? A, the vector dot b, right? So, and at the end of the day, it evaluates to a scalar. So why is that so? So you see, whenever you take the product of two vectors, this is how the I and j thing works. So when you think about it in the components of each other, now when you think about it in the components of each other, we have this, for example, in two vectors, right? So we have this to be components of I, direction of I, and then we have it to be direction of j. They are mutually perpendicular to each other, so 90 degrees. Okay, so since they are at 90 degrees to each other, we have it to be such that this I is fully horizontal and this j is fully vertical as well. So when we take I dot I, now when we take I dot I, it eventually evaluates to 1. Okay, so you see this section of it is probably something I should have discussed when we talk about the product of two vectors, but don't worry, I'll talk about it like that. I'll talk about it soon. So when we take I dot I, we have it as evaluating to 1. Now when you take I dot j, now it evaluates to 0. When you take j dot I, it evaluates to 0, but you take j dot j, it evaluates to 1. Okay, so that is what happens in the dot product, and this is all about because of the fact that I and j are perpendicular to each other, and we're going to show you how that works with the aid of an example and how it so happens like that. So this is how it works now. Okay, so say for example we have your A multiplied by dot your B. For dot your B, sorry, I should have said dot. That's the appropriate way to put it. So we are going to have it to be your ax in the direction of I plus ay in the direction of j dot, and then we have it to be your bx in the direction of I plus by in the direction of j. So it ends up to become axi in direction of I multiplied by everything, right? So that's bx in direction of I plus your by in the direction of j plus your ay in the direction of j multiplied by bx in the direction of I plus by in the direction of j. Okay, so now we have it to be ax times bx. We're going to have it to be ax bx. Now I times I, we look here, it gives us, it evaluates to 1. So we have this to be 1, just like that. So now we go here, we have what? AXI times BYJ. The I dot J gives us a 0. So this evaluates to 0 plus now AYJ plus times BXI also gives us a 0. And finally, we have AY and BY, but J and J dot J gives us 1. So we have it to be AY BY. So that means that all your A dot B, the dot product of the two vectors, is simply just multiplication of the components in the X plus with the components in the Y as well. So that's what we have as a result. Okay, so that's how to take the dot product of the vectors. So that brings us back to this part of it. What exactly was going on here? So you see, when we have two vectors now, when we have two vectors together here now, the angle between them now is going to be given as this. Let's say we have two vectors. Let me actually use this thing now. Okay, and that's the other part of our question now. So angles between vectors. So let's assume we have two vectors now that let's say we have this vector here, just for example, and then we have another vector here as another example. So in between these two vectors is an angle theta, right? So it's an angle theta. So what's the product? What's the this thing now? The angle between them, these two vectors, let's call it vector A and vector B, is usually given as A dot B. You take the dot product, is usually equal to their magnitude. So that's the magnitude of A, the magnitude of B, and we have it to be cos theta. So that is the relationship between a dot product and a distance. But how did we come to know about this, and how do we know about this particular that, oh, when you take your I dot I you get 1, you take your I dot J you get 0, your J dot I is 0, and your J dot J is 1? How did we come about that kind of a relationship at all? So just work with me now. So let's imagine that we have a force like this. Okay, so let's imagine that we have a force working like this. You should remember that a force is a what? Is a vector. So as it is here, it can be broken down into two components, right? And the components are the horizontal components, which is Fx, and the vertical component, Fy. Okay, so if you look at it closely now, the angle between the vector itself and the horizontal is theta, isn't it? Okay, so the horizontal is the horizontal component, that's what I mean. So and then the vertical component and the horizontal component are perpendicular to each other, so that's the angle 90 they have there. Okay, so how do we get the vertical components and the horizontal components now? So your horizontal component Fx, we are going to apply SOHCAHTOA to it. So you are going to say something like sine theta equals to opposite over hypotenuse. Your opposite is this, your Fy. So that's the magnitude of Fy over, what do we have it as, F. So your Fy is equals to F sine theta. Is that right? So that should be an arrow here. That's for the F. Okay, so that's F. But in this case, we are mostly concerned about the magnitude. So that's magnitude like that. Okay. Then we have the cos theta as well. Cos theta is equals to adjacent, which is the Fx, over the hypotenuse, which is F. So similarly, we have that Fx is equals to F cos theta. So that means that whenever you take Fx now, you have it to be of F cos theta, and then your Fy is equals to F sine theta. Okay, so when we bring that same idea now, and as far as the theta is the angle between the distance, so when you bring it to the world of your what's it called, your I dot I now, for example, now So when we are going to apply this and mix it with what we have here now as the angle between vectors. So when we have your I dot I, remember this is what your I dot I looks together. These are the vectors. So this is your I and this is your J component, okay? So both are mutually perpendicular to each other. So when we say I dot I, for example now, so those are your vectors, this thing, and so you are caring about the what? The magnitude. So since they are unit directions now, the magnitude are both 1. You're going to have it as 1, 1, and you have it to be what? Cos 0 degrees, and cos 0 degrees is 1, and that's what we have there. And similarly, we have I dot J, which is equals to 1, 1, and we have it to be the difference, the angle between the two of them now. The angle between I and J is 90 degrees. That's going to be cos 90 degrees, and that is 0. J dot I is also the same thing as when you have your 1, 1, and you have your what? Your cos 90 as well, because those are the angle between them, and that's going to 0 as well. But if you take J dot J, now J and itself are 0 degrees away from each other, so you have it to be 1, 1 cos 90 degrees, which is equals to 1 as well. I mean cos 0, that's the distance, so it makes it equals to 1. So in a nutshell, this is all you need to know. You need to know that first of all, the angle between two vectors is given by, the relationship of your dot product. The dot product is A dot B, given by the magnitude of A, the magnitude of B, multiplied by cos theta. And that from number 2, you can also say that your dot product is the product of their of their components, like this. Yeah, it's going to be AX BX plus AY BY, like that. Okay, so if you take this, your equation 1, and you make it a subject formula, you are going to arrive at something like, you make cos theta the subject formula. You can say that cos theta is equals to A dot B dot as a fraction, as a vector, over magnitude of A over magnitude of B. And those are 3 relations that hopefully are very useful. So that's about the dot products and the angles between two vectors. Let's take questions from the next video. Thanks for watching.